I'm sure some of you know something about inheritance and composition, so this will be just a refresher. So in Louder, okay. So in class-based object-oriented systems, composition and inheritance are the two primary methods of actually creating and designing your objects. Now, most of the time we hear people say composition over inheritance, and half the time people don't say exactly why. So let's discuss this a bit and talk to understand what this is all about. Let's start with object inheritance, which is in inheritance, which is what Ruby is usually using. Relationships are defined as a hierarchy of classes with subclasses. Subclasses share the parent's class behavior. So if you define something in the parent, the children will have the same behavior. Inheritance describes object in terms of is a relationships, and we'll look at that in a few moments. And then it's a mechanism for automatic message delegation. So again, as I said, inheritance is at its core a mechanism for automatic message delegation. It creates a relationship such as that if one object can't respond to a received message, to a specific method, it delegates that message to its parent's class, its creator. It goes up to the parent and looks for the method. So we don't have to write a lot of code to make this happen. We get this automatically for free by using inheritance. And let's look at one example. So in our example, we have a class of a bird, and the bird has a method called speak. And we have a penguin, a duck, an owl, and a chicken that all inherit from a bird. If you can see in penguins, we don't have the speak method defined, but if it doesn't have it on penguin, it will go to bird and find it. In the other ones, so in this case, the bird is a parent or base class, and then all the other ones are children or subclasses. And the children or subclasses need to be more specific or more concrete than the abstract class. So it's defined things that are relating more to the actual classes. They specialize more than the superclass. When using parent classes and children classes, we can use the super. We can use super to invoke behavior in the parent classes. So sending super in any method passes that message up to the superclass chain. In this case, we have a property class which initializes street, suburb, state, and postcode. And then we have an apartment which inherits from property. And because it's an apartment, it also needs a unit number. And as you can see here, what we need to do is we need to call super first to be able to initialize and set all those variables, and only then call unit. We can't actually, so super needs to be first in this case. It doesn't usually, but in this case it is. And the problem is because there is a specific order for the arguments to come in, and unit is stuck in the middle. We have to call super first. To fix that, we can use something else, and we can use keyword arguments instead. And then we're removing the dependency on the same order when you pass in the arguments. Much better. But not really the topic of this talk. So let's continue. By using the keyword super, we can invoke the code in the parent class at any point in the overriding method and still be capable of adding functionality. So in other words, the overriding method can do the same action as the parent class and more on top of that. Let's add some new feature requests for our birds. In this case, we want to add that our birds can fly. If we look at the structure that we have now, where do you think we should add the fly method? Anyone?
To duck, owl, and just duck and owl, actually. Owl. Chicken. Ducks could fly.
Yeah. True.
Penguins can fly.
Let's look at one way of doing that. So in one way, before we just add them to specific classes, we add them to the bird class. And in this case, you know, all our birds can fly, but we have a problem with penguin and a chicken because they can't really fly, right? So we need to raise something to say, actually, sorry, no, we can't do that. There is a better way, which is what Odin mentioned, which is only add them to duck and owl, the actual birds that can fly. And in the parent one, we can raise not implemented error. So we get something if we're trying. So it tells us there is a problem. It's a bit more descriptive with the error message. But the problem with this structure is that we have duplication, especially if we have a lot more birds that suddenly we need to define how to fly for each one of them. The solution for that, talked about that. The solution for that could be a mixin. Does everybody know what a mixin is or have they heard of? Cool. Let's cover that just quickly. So mixins are Ruby's answer to multiple inheritance. They allow us to share behavior between classes. Mixins are Ruby modules that we include in another class. When we say that we are mixing in more behavior into a specific class. When we do that, the class will have access to all the methods that are in that module, in that mixin. So think about this relationship as behaves like a. So if we talked about before that we have a duck or is a bird, with a mixin, we will have a duck can fly or behaves like a flyable object. In Rails, active support concerns allows us to save a few lines of boilerplate code to create mixins. And we do it this way. We create a module. It usually lives in app modules concerns. And we say extends active support concern. We add the method that we want, and then we include that method in whichever class we want to use. Does that make sense so far? Cool. Problems with... There's a bit more code that you need to write if you don't have that. And I can find you articles to show you. So mixins. Mixins are modules that are inheritance by a different name. So as I said, think of them as a behaves like something. A class can have only in inheritance, pure inheritance, a class can only have one superclass, but it can mix in as many modules as it wants to. Mixins are added to the lookup chain, which we will talk about in a minute. They can be shared by multiple classes, so you can share behavior. They cannot be instantiated and do not have a state, which is a problem, which we'll talk about in a second as well. They might be used by a single class to group functionality, and doing that may be a terrible idea. So let's discuss why that is a bad idea. This is an example from a project I worked on many years ago. And this is the user class, which is a God class in this case. It has, before all the modules that we included in, it has about 360 lines of code. Then add all those modules. So the code on user actually inflates to a lot more than 360 lines of code. Adding those modules makes the class harder to understand what the object does because everything hides in another file. They inflate the number of methods available in a class, and they make classes look slim because you have less lines of code, but they really just hide the mess in another place that then we need to look for in another place to find those methods. They mix in, as I said again, interfere with the method lookup chain. Now, this is talking about the Ruby object model and how objects find the methods defined on them. Again, topic for another talk, if any of the newbies want to cover that. So in this case, we have a duck. We injected flyable into duck, but its superclass is a bird, which its superclass of bird is an object. It's entirely possible for a hierarchy to contain a long chain of superclasses, each of which includes many modules. When a single class includes several different modules, the modules are placed in the method lookup path in reverse order of module inclusion. Thus, the methods of the last included are the ones that are encountered first in the lookup path. Other things that are not great with mixins, they use the same namespace as the parent class, the class that they're mixed into, which can cause name conflicts. They have access to instance variables from the classes they are mixed into, but they cannot accept initializer arguments, so they can't have their own states, which means they are impossible to test in isolation. You can only test them within the context of the class that they've been mixed into. If you want to test that fly works the way you want it, you need to instantiate a duck, and then test that the duck can fly. Not great for specs. I think in our spec you have behaves like, that you can group the same specs together and include them in various specs for different objects. But this is just trying to solve this problem or a similar problem. So mixins are code smells, which again could be another talk. And how to deal with that code smells, there's a few ways, but one of the ways is composition. When I was preparing this talk, I looked at the definition of compose or composed in a dictionary, and there was quite a few more definitions than that, but those are the ones that I liked. For example, to make or form by combining things, parts, or elements. To constitute, to be or constitute a part of an element, to make up the form the basis of, to put or dispose in a proper form or order, and to bring oneself to a condition of calmness, repose, calm, tranquil, and serene, which is usually what you will get if you use composition more than inheritance in many cases in your app. What? Music is one. Also, print and print design, you have compositions as an example. Yeah. Composition is the act of combining parts into a complex whole, such as the whole becomes more than the sum of its parts. We can think of it as a has-a relationship. So if we think of a car has many wheels or has a wheel. So rather than lock down the behavior sharing to a single path that goes up to the parent and to another parent, we can share code among objects with composition. We can make more objects which handle behavior individually and test that in isolation. Typically, this means that we build our objects to call methods or forward certain messages to additional objects. And these objects contain more or better information about handling the message. Let's have a look at a couple of examples. So the top example is an inheritance. So in this case, we have a product and we have a book and a video that inherit from product. In this case, we can say that the product is the parent class and the book and video are the child classes. The object, again, are assembled statically. You can't change the parent in this case, and it's static. On the lower part of this code, you have an example of composition. In this case, we have a couple of different concepts. We have a product, and we have the concept of a deliverable. And in this case, we say that we compose a product with a deliverable. And a deliverable can be a book or a video or anything else. So instead of a book being a product has a deliverable. Going back to inheritance, let's say that in our product, we want to deliver the product that we have. In inheritance, you might do something like a case that if this is a book, then post the book to whoever bought it. If this is a video, then stream it or have a download link being able to use. And then you just call book.new.deliver. Also, we talked about mixins. You might have that some products are downloadable and some products are commentable, and each one has a different behavior, and then you mix those mixins in. Let's try and look at that. in how you would do that in composition. So in composition, again, we said we have a product and we initialize that with a deliverable. So we compose a product with a deliverable. But then if you will see on line 5, we say we delegate deliver to deliverable. So product doesn't care how to deliver the product. It delegates that responsibility to either book or to video, and each one knows what to do when they need to deliver that product, to deliver themselves. Also, another example, for example, if we have product and we say we want to email a receipt to a user, we will have email to a user and we instantiate a mailer. And in book, we might want to add more things. So we will call super to call on the parent behavior and then add more things in that case. Again, to know exactly what's happening, we can't see that in product. We need to look at product and then look at book to be able to see what's actually happening. In composition, once again, we are delegating everything. So we instantiate a product with a deliverable. And in email too, we explicitly say deliverable email to user, and then let whatever class do whatever they need to do over there. So this is a bit more explicit rather than before. So I mentioned things that inheritance is more static and composition is more dynamic. And it's a bit funny because Ruby is not a compiled language, so everything is evaluated at runtime. It's not a static language, so claiming that anything is assembled statically may sound like nonsense. However, there are several ways in which inheritance hierarchies are essentially written in stone or static. For example, we can't swap out the superclass once it's assigned. We can't easily add or remove behavior after an object is instantiated. We can't inject a superclass as a dependency. This is why we use mixin. We can't easily access an abstract class methods directly. Composition as a dynamic option, for example, is we can easily change out a composed instance after instantiation. We can add and remove behaviors at any time using decorators, observers, and other patterns. We can easily inject composed dependencies, which is the best thing for testing. And composed objects are abstract, so we can use their methods anywhere. As long as the places that use them, as long as the composed objects answer to the same interface, and we'll talk about this in a minute. So how to decide which model to choose? Using subclasses and hierarchy introduces a subtle problem into the domain model. It assumes that our models follow a hierarchy. That is, it assumes that our objects fall into a tree-like structure, which sometimes works, but sometimes doesn't. Composition, on the other hand, provides several ways that work better with objects. Once we build objects with a reasonable interface, we can combine them endlessly with minimal modifications to existing class structure. So the benefits of inheritance: you have free message delegations. If I don't have this message, I'm going to look up into my parent to look for it. Methods at the top have widespread influence, so you don't need to write much and all the children have the same methods. Correctly modeled hierarchies are very reasonable. Big changes in behavior can be achieved by small changes in code, so we can easily create new classes to accommodate new variations of objects. Correctly modeled hierarchies are very easy to extend. The hierarchy embodies the abstractions, and every new subclass plugs in a few concrete differences. The cost of inheritance. If the hierarchy model is incorrect, adding behavior becomes costly. Because the model is incorrect, the new behavior won't fit. So in this case, we will be forced to duplicate or restructure code, especially if the change is near the top and you don't have a very good hierarchy modeled correctly, then you will have to make a lot of changes across all the subclasses. We also have a very high cost of making changes near the top to an incorrectly modeled hierarchy. Small changes in the top cause big changes down the hierarchy, which sometimes you don't know what they're going to cause. And it's impossible to hide behavior when new subclasses represent a mixture of types. So mini quiz, again. In this case, we have a movable type, which is, or let's start with, we have a boat, a car, and a plane, which you can think of all of them as an object with engines, and they inherit from vehicle, which inherits from a movable object. What do you think about this hierarchy? Why does it depend? True. Yeah, well, I think this is a questionable hierarchy because both car and plane are very distinct, would have very distinct behaviors, that it would be very hard to justify this hierarchy in general. So the problem that if we did do this and then we are now set in stone that the vehicle is the parent, and we have some string attached to parent. And when we create a subclass of an existing class, then you're not really creating two separate entities. Instead, you're making two classes that are bound together by a common implementation core. So inheritance by nature tends to marry the subclass to the superclass, and changing the behavior of the superclass will affect on the subclasses. Composition, on the other hand, allows objects to have structural independence, but at the cost of explicit message delegation. So let's look at some benefits of composition. It has a natural tendency to create, when you use composition, you have a natural tendency to create many small objects that contain straightforward responsibilities and that are accessible through clearly defined interfaces. So you have more explicit objects that you can see what goes on instead of looking at what happens in the superclass. Composed object, because composed objects deal with their parts via an interface, adding a new kind of part is a simple matter of plugging in a new object that honors the same interface. So it doesn't need to be a duck, but as long as it responds to the same methods or the same interface, you can use that in another place. Well-composed objects are therefore easily usable in many places. It's easier to test in isolation because you just inject your dependencies and you don't have to worry about all the rest of the context in the environment. And it's easier to extend to a particular concept. Sandy Met said, at its best, composition results in applications built of simple, pluggable objects that are easy to extend and have a high tolerance for change. It does have costs though. So a composed object relies on its many parts. Even if each part is small and easily understood, the combined operations of the whole may be less than obvious. So you might understand exactly what's in front of you, but seeing the whole system might be a bit more difficult, which is not necessarily a bad thing because you know that whatever you see and whatever change you make only happens in that place and you're not affecting places that you're unaware of. So it could be good and bad. And but the cost of composition is you don't have automatic message delegation. You have to be explicit with the message calls that you're making to other objects. So another mini quiz. In this case, we have a program with a person class, and we also have an employee and a customer, and they both inherit from a person. Okay, so far? What happens when a given person is an employee who wants to buy something with an employee discount? Do you think that hierarchy still works? Yes, no, maybe? Depends. It depends, true, but I think it will work a lot better as composition. So this is an example of if we have a person class that will have probably a first name, last name, email, and everything that you need. But then you have an employee class, which is composed by a person. We have a customer class that is composed by a person, and that person can be an employee. And then we can deal with a customer and a product and doing transaction, whatever we need. So that makes more sense to me. So the main takeaways that I want you to take from my talk is Think about inheritance, mixins, and composition as relationship as is a bird, for example, behaves like a flyable object or has a will. Or inheritance give you automatic message delegations that we can look up to a superclass to find whatever we're trying to do. Just make sure that your hierarchy makes sense. Compositions, on the other hand, allows object to have structural independence, but at the cost of explicit message delegations. We need to be explicit at the calls that we are making. Composition results in smaller, simpler objects that are more focused, pluggable, easy to extend, and have high tolerance for change and are easier to test. So if you're not sure whether inheritance will work for you, like it's not obvious that inheritance can be great, but if you're not sure that it will work for whatever you're trying to do, please try composition. Some further resources. Sandy Metz has a great talk that's called Nothing is Something, which talks about that and gives another great example of why composition works great. And then there's a couple of articles and a couple of book chapters from various books. And that is me. Thank you very much.
Bring you the mic every time. Hi. First up question, you're saying mixins are impossible to test. I'll refute that because we can easily mock out the dependency of the parent class and the subparent classes. That's trivial. So they're not impossible to test.
Yeah.
But I agree with you. Composition is better than inheritance. Yeah. Fundamentally, one of the things that you should have mentioned was the Liskov substitution principle.
Yeah, I know. I didn't want to.
So Sandy Metz talks about it in the book that you quoted. And actually the whole book, everybody should read it. Sorry. the whole book, everybody should read it. Another thing, dependency injection. You did mention it kind of briefly in the notes, but it's really important to distinguish what you're actually doing there. Just injecting an object into another class. Yeah. That's how we create a has-a rather than an is-a. Exactly. So I think that's about all I've got.
Oh, correct.
Do we have questions as opposed to statements?
No, it's a good statement.
Yes. Anybody else? Cool. Thank you, Ellie.